For this problem, we're supposed to find the general antiderivative of g of x is equal to x times x plus 4 quantity squared. To do this problem, the first thing that I'm going to do is multiply out. So g of x is equal to x times x plus 4 quantity squared. Now, if I square, I get x squared plus 8x plus 16. And then if I multiply through by x, I get x cubed plus 8x squared plus 16x. So that is the function where I have multiplied it out. So in order to find the general antiderivative, the general rule is that I add, for when I have a polynomial like this, or powers of x, I add 1 to the exponent and then divide by the new power. So the general antiderivative of x to the third is going to be x to the fourth over 4. The general derivative of 8x squared is going to be 8x cubed over 3. And the generalized antiderivative of 16x is going to be 16x squared over 2. And that simplifies a little bit. I can write this as x to the fourth over 4 plus 8x to the third over 3 plus 8x squared. Now, hopefully you're screaming at the screen right now because there's one thing that I did not write down, and that is plus the general constant of integration. And so what I have here on the last line, that is the general antiderivative, the most general function whose derivative is the top line. Okay, now that's the end of the solution. So I could stop the video here. And one thing you can do for a problem like this is check your work. And to check our work, let's take the derivative of capital G. And the result ought to be exactly what I see here on the top line. The derivative of x to the fourth over 4 is going to be 1/4 times 4x to the third. The derivative of 8/3 times x cubed is going to be 8/3 times 3x squared. The derivative of 8x squared is 8 times 2x, and the derivative of constant is c. And so this is x cubed plus 8x squared plus 16x. Here I can factor an x out. So x times the quantity x squared plus 8x plus 16. And lo and behold, I end up right where I started, x times x plus 4 quantity squared. So the last line in purple, where I'm drawing these arrows in boxing, this is the answer. The work that I did here in red is something that I can do to check and make sure that I did the work correctly.